Hello, everyone. I'm Nicole Racchio, and I'm an insights lead from a team here at Google that created data tools such as news consumer insights and real-time content insights, specifically for news publishers. I have my colleague Chris here as well. I'll let him introduce himself.
Hey, thanks, Nicole. My name's Chris Lamont from the Web Ecosystem Consulting Team, which is a team that works with Google's partners, so publishers and advertisers, with the overall goal of making the web a better place, which in many cases is comes down to improving performance. In this case, core web vitals.
Awesome. Thanks so much, Chris. I want to take a minute to introduce some free data tools that were created for publishers to use. News Tagging Guide is basically a publisher's easy button for setting up Google Analytics tracking. As a publisher, you can identify behaviors you want to track and easily generate the tags to put on your site. News Consumer Insights revisualizes your Google Analytics information to make it more simple and useful for publishers to analyze and take action on their audience insights and understand their reader funnel. And the third, Real-Time Content Insights, takes advantage of your real-time data from GA and allows publishers to see which articles or videos are trending. In the process of building our tools, we saw how crucial page speed was to optimizing engagement and loyalty. 50% of users leave a site if it takes more than 3 seconds to load. 47% expect web pages to load in under 2 seconds, and 52% of users say load time plays a role in how loyal they are to a brand. Earlier this year, Google announced that it would be using page experience as a ranking signal and rolled this out to mobile this past August. It will be rolled out as a signal for desktop by the end of March 2022. Page experience is crucial to the success of any website as it measures how users perceive their interaction with a given site, beyond its pure informational value. It's an important signal, among many, that Google's consider when generating search results, so it's important to be aware of it. One component of page experience is a common set of page speed signals called Core Web Vitals, which is the focus of this session. By the time you finish watching this video, you'll have a basic understanding of Core Web Vitals, what they analyze, what tools are available, and you'll have a basic framework to help you optimize. Core Web Vitals are a common set of page speed signals that analyze 3 important dimensions of page speed. Loading experience, known as largest contentful paint, or LCP. Interactivity, or first input delay, known as FID. And visual stability of page content, known as cumulative layout shift, or CLS. In many ways, Core Web Vitals quantifies a user's first impression of a web page, and we always want to make a good first impression. To do that, let's dive deeper into the 3 dimensions of Core Web Vitals, beginning with LCP. So, largest contentful paint, or LCP, in simple terms, is a measure of loading performance or how fast the main or largest content appears on a page. This should occur within 2.5 seconds of a user landing on a page. The next measure is FID, or first input delay. It's a measure of how soon a page is able to respond to a user interacting with it. For example, clicking a link or tapping a button. Just like I'm going to do now to move on to the third and final Core Web Vital. CLS, or cumulative layout shift, is a measure of the visual stability of a page as it loads. Have you ever started reading an article and before finishing a sentence, the text moves and you lose your place? That's what CLS measures, and ideally, a page should have a CLS score of 0.1 or less. Now that we've familiarized ourselves a bit with Core Web Vitals, what's the next step? How do I even measure Core Web Vitals and say, I don't pass one or a couple or even all 3 of the Core Web Vitals? What do I do then? Don't panic. We've asked our colleague Chris and resident Core Web Vital expert here at Google to join us to answer some of those basic questions and take us through some of the basic steps he takes when working with publishers to evaluate Core Web Vitals on their sites. So I will pass it over to Chris now to do a walkthrough for us.
Thanks, Nicole. So what we're going to look at is use the Excelsior Citizen as an example of a site that will audit and evaluate and look at ways to improve core web vitals. And thank you to the Excelsior citizen for giving access and volunteering your site for this audit. So the first tool I look at when I'm evaluating a site is I go to PageSpeed Insights to get a general sense of how the site performs. So you can navigate to pagespeed.web.dev, and we'll have a link to that in the description. So once you input your URL and click Analyze, you'll see a report like this, which is split into two sections. The top section is what we call field data. So it's how actual users are experiencing the site. And the second section is called lab data. So this is a measure of the site as it is run in a controlled environment, so not from a real user's device. But the first that we'll look at is the real user data. So here we're looking at mobile devices aggregated from the Chrome user experience report, so users using real mobile devices. And this is aggregated at the origin level. So on some sites that meet a certain traffic threshold, you'll be able to see data at the URL level, but here we're going to look at the overall origin. So some of these metrics Nicole just mentioned are the core web vitals. So we have first input delay, largest contentful paint, cumulative layout shift, and first contentful paint, which is not a core web vital, but is still a very important metric. So these numbers that we see here, so 6 seconds for largest contentful paint, that is what users experience at the 75th percentile. So if you picture 100 random users, 75 of them will experience a largest contentful paint better than 6 seconds. So the largest contentful paint will appear faster than 6 seconds for 75% of the users and worse than 6 seconds for the remaining 25%. And across the origin as a whole, 75% of users will not experience any layout shift. So that's a very good signal. But field data doesn't necessarily tell us the whole story. So we can look at the lab data as well to give us a better sense of what we can dig into to, for example, how we can improve largest contentful paint, because the field data doesn't really give us any indication on how we can improve largest contentful paint. So as we scroll down, we'll see that in the lab, the largest contentful paint metric actually matches pretty closely with what we see in the field, which is a good sign, because that gives us an indication that the lab data represents what a real user might experience. So how can we actually improve LCP based on what this Lighthouse report is telling us? So we can look at some of the top recommendations and use that to inform some of our decision making, and we'll dive a bit more into this later. So the first recommendation, serve images in next-gen formats. So this is pointing out a few images served on the homepage that could be optimized. So that's a good place to start, and we'll look into that. We can properly size images. So on mobile screens, we don't need to serve huge images to get a good user experience. And thirdly, we can reduce the initial server response time. So on this page, the time to first byte was a little over 5 seconds, almost 6 seconds. So we can look at that more closely as well when we dive a little deeper into the page. So that's all I wanted to show for this particular tool. We can also look at desktop. So currently, Google search uses, for mobile search, it uses Core Web Vitals as a signal. And starting in February, it will start using Core Web Vitals as a signal for desktop as well. So that's something to be aware of. And we can see here how the performance on desktop differs from mobile. So the next tool I wanted to show is the Google Search Console. And the difference between the Google Search Console and PageSpeed Insights is that the Google Search Console is only available to the owners of the page, unlike PageSpeed Insights, which is available to anyone with the URL. So that's, and because of that, the Search Console gives a bit more detail on the page. So let's navigate over to search.google.com/search console and look at what the Search Console is telling us. So firstly, we can navigate down to Core Web Vitals because that's what we're interested in. And from there, we can navigate into mobile because that's currently what we're focused on. And this data is based on the same data as PageSpeed Insights, that same real-world data from the Chrome User Experience Report, but it's aggregated a little bit differently. So here, URLs are grouped into 3 categories. So there's good, needs improvement, and poor. And the way it's categorized is a URL gets it looks at the worst core web vital and for that URL, and it gets the whole URL gets assigned the status of that worst metric. So for example, if you have a very good LCP and a very good CLS but a poor FID, that URL will show up in the poor section in the Search Console. So in this section, we see that all the URLs have the same issue. So URLs are grouped based on how similar the content is. And here we only have one group. But because all these URLs are very similar, it makes it easy to optimize for because they all have the same issue. And that issue is their LCP, which lines up with what we were seeing on PageSpeed Insights. So across all of these pages, the aggregate LCP at the 75th percentile is 6 seconds. So finally, let's dive into how we can actually improve LCP. So for that, we'll take a look at the page itself in Chrome and use DevTools to try to dig down into what exactly is causing this high number for LCP. Okay, so here's the page loaded on the desktop, and to look a little more closely, we'll go into DevTools. So you can right-click and click on Inspect to open up DevTools. And I like to look at it on mobile, so you can click this little box up here to put it in a mobile viewport. And there are a few settings that I like to use to emulate a real user. So the first is going into the Network tab and disabling your cache so that when you reload the page, you aren't using any cached assets, and it'll be similar to a new user traveling to the site for the first time. You can do additional tests with the cache enabled to see what it's like for a repeat user, but I prefer for my first run through to disable the cache. And I also like to slow down my network a bit to emulate what it's like for a user on a slower mobile device. So for that, you can go into the Performance tab, and under Network, there are a few preset options. I find these to be a bit on the too slow side. So I add a custom one of around 10 megabits. So you can add a custom profile here. Let's do 6 megabit for the test. So you can do 6,000 download, 6,000 upload with a 100 millisecond latency. Okay, and let's refresh the page with all of these settings enabled and see what we come up with. So this is profiling a page, and this will help give us a sense of uh, where the areas for improvement are. All right, so after this loads, sometimes this takes a second, but luckily I have another tab here with one I previously ran. So this gives us an overview of all of the requests and all of the CPU activity and that occurs when the page loads. And it also points out when the milestones are for certain web vitals. So if we're trying to target LCP, what I like to do is find the LCP in this timings section and then work backwards from there. So let's start with that. So if we go to this LCP flag and hover over it, it actually highlights the image, in this case, that was the LCP. And you'll notice that it highlights an image in this rotating carousel. So let's work backwards from there and try to find out how we can improve this LCP. You'll note that in this particular run, the LCP, if we follow this line upward, happens around 11,000 milliseconds. So 11 seconds into the page is when this image appeared. So how can we work backwards? So one way we can do that is we can look for what happens right before the LCP occurs and then work backwards from there. So you'll notice if we line this up correctly that this particular image downloads right before LCP, and that's telling because that indicates that if we can get this image to load faster, then we can improve our LCP. So let's first verify that this image that completes right before LCP is the correct image. So for that, we can go into the network tab and look for this particular image, which is, it ends in 900 by 473 px2, and find that in the network tab. Okay, so if we scan through here to find that image, we'll end up here, which looks correct. This is the same image that was highlighted as the LCP in the previous tab. So how can we get this image to download more quickly? So for that, let's go back to the Performance tab. So you'll notice that this image does not begin downloading until around just before 9.5 seconds. So 9,468 milliseconds is around the time this image begins downloading. And there are many images that start downloading around that same time, and there are some images that start downloading even earlier. So for some reason, there are other images and fonts that download before this very important LCP image. So let's look into these other images that begin downloading before this image that we care about. So there's another image that's very similar. So this one in particular here, and let's find this in the network tab. So I believe that's this one here. So this is actually a lower resolution version of the same image, which makes sense because oftentimes if you're trying to get images to load faster, you might use a lower resolution version of an image. But in this case, we didn't get, now we can use a different aspect of the tool, this timeline up here, to sort of narrow down when these images start to load. So if we scroll through here, you'll see that the image doesn't actually display until around the time when that larger resolution image loads. So here around 11 seconds, the same time as this higher resolution image finishes loading. So it seems like in this particular case, the low resolution image is not appearing at all, and it's not displaying. So one thing we could do is figure out where in the code, where in the logic, the logic is for displaying this lower resolution image, and get that to work properly, so that when this image completes downloading, then we can show the lower resolution image, and we don't have to wait for the larger one. So that'll get us part of the way there. So let's say we fix that issue, and now we're showing the LCP image at, say, 9 seconds when the smaller images finishes loading versus the 12 seconds we had previously. What else can we do to improve? So for that, we can continue to work backwards. So here we can see all this yellow is the JavaScript loading. So that's in some cases a priority. You have the CSS. So this whole section looks pretty good. All the CSS, it doesn't take more than, for all the CSS, it takes around half a second for all that CSS to load, which is not bad. There's a little bit of blocking JavaScript, which is necessary to display anything, which also takes half a second from when it begins to when it ends, and that's pretty in line with a high-performing site. So if the CSS and the blocking JavaScript is not the issue, then there's really one thing remaining, and that is the response from the server itself. So if we look at, if we extend this a bit back here, we'll see that this initial HTML download is probably one of the biggest culprits in this long LCP. So let's find this network request in the network tab. All right, so let's filter this to all. It should be the first one. All right, let's scroll to the top and find it here. And let's look at the timing. So the number that sticks out, this long bar here, is the time to first byte at 7.27 seconds. And that's how long we're waiting for the server to respond to our initial GET request. And this is very important because nothing on the page can happen until we get that HTML response. And there are many ways to improve this, but they all occur on the server side. So one way we can do it is we can optimize the server's application logic to prepare pages faster. So if you're using a server framework like WordPress, they may have recommendations on how to do this. This may be an issue with a database query, so you can optimize your queries or your database indexes to optimize that. Or it may simply be a matter of the server hardware, where you need to upgrade your CPU and memory. But none of that, unfortunately, can be seen from this perspective when we're looking at it on the client side. And for that, there are many additional resources I'd like to recommend. So I'll take this opportunity to plug web.dev, which is a very useful resource for all things performance. So let's say we know we need to optimize time to first byte. How might we do that? We can simply search for time to first byte, and here we go, reduce server response times. So we can take a look at this article and see if anything here might help reduce that number and help get this 7 seconds down to hopefully under a second, maybe even down below half a second, which would be ideal. And fixing that issue, I think, would go a long way on this particular site to improving LCP, because that would essentially shift this entire graph to the left by however much we improve time to first byte. So that's LCP. So that's the metric that was flagged by both Lighthouse and Search Console and PageSpeed Insights as a metric to work on. But I do, even though this page doesn't have big issues with the other metrics, I want to point out how you might improve those metrics if you're having issues on your own page. So let's take a look at first at cumulative layout shift. So as Nicole mentioned, cumulative layout shift is a measure of how much content shifts on the screen throughout the life cycle of the page. And one good way to evaluate that is simply looking at the page as it loads. And in this view, in the Performance tab, we can look at it frame by frame. So let's start at the beginning. So here, the first view we have of the page, we have some of the text, no images yet. And then as the page begins to load and some images come in, then we'll see some content shift. So here, as the logo loads, that pushes the Excelsior Citizen name down, causing a shift, which may cause a bad user experience. And then as it continues to load, we fortunately do not get much more shift. So how can we fix this one big shift here where we have the logo load and the Excelsior Citizen name getting pushed down? So one way to do that is to carve out space for this image before it loads. We can add in the height and width to this element before it loads, so that when it loads initially, even before the image itself loads, we know how big it will be, and this name will render in the correct spot before the image loads. How else can we identify layout shift issues? So in the Experience tab, this will actually highlight layout shifts as they occur. So let's take a look at this particular layout shift we were just talking about. So if we look at the summary for this shift, we'll get a good overview of this shift itself and how much of the screen it's affecting. So in this case, each shift is assigned a score, which is a product of how much of the screen moves and how far it moves. So in this case, this particular element received a score, or this shift rather, received a score of 0.14. And it will tell us where it moved from and where it moved to. So here we can see that from the highlighting, moved from the top of the screen down by about 140 pixels or so. And that gives us a score of 0.143. There are some other shifts that happen in the same frame, and this will give us an idea of where and how those shifts are occurring as well. But the important thing to note is that this Experience tab will highlight the shifts, and you can use these coordinates to identify what's shifting and how much are they shifting by. And then use the score to identify whether those shifts are a problem or not. So ideally, your cumulative score will be under 0.1 total. So in this example, these few shifts add up to slightly above your shift budget. So the final metric I wanted to look at is first input delay. So first input delay is a measure of how long the browser takes to respond to user input. And that is a function of activity that's happening on the main thread. So let's look at the main thread section here to see where some problems may arise. So let's zoom in a bit here. So if we look at the main thread, any task that takes longer than 50 milliseconds will receive a small red flag here. And the way that main thread tasks can affect user experience is, so let's say a user interacts with the page sometime at the beginning of this long task on the main thread. The user will have to wait for the remainder of that task to finish before the page responds to that input, which is the reason that long tasks, the longer the task, the longer a user may have to wait. So Chrome will flag any task longer than 50 milliseconds, which is deemed the longest reasonable amount of time that a user should have to wait. So on this page, there aren't many long tasks at all. In fact, there's only one or two. But let's dive into this one and see if there's anything we can optimize here. So in this example, this function call, which takes about 80 milliseconds, is coming from jQuery. So there's probably not much we can do about that. We can dig into it a little bit more to see if that jQuery function we're calling, say, is calling a very broad selector, which takes a lot of time. But in general, most of the time, long tasks that you'll see come from third parties, which are taking up, which have many long tasks, or first parties such as your JavaScript framework doing hydration. So unless you're seeing a big issue from those particular functions, say the third parties or the first parties, then you generally don't have to worry too much about a few long tasks. If you start seeing very long tasks up into the 500 millisecond or even larger in the second range, then it becomes much more of an issue. But in either case, you can use the main thread feature here in DevTools to help identify some of those tasks. And so that covers the three web vitals and how to improve each of them in DevTools. So now I'll kick it back to Nicole, who will give a quick recap and sign off. Thanks.
Thanks so much, Chris. So basically today, As a recap, these are the resources mentioned throughout our session. You'll find the hyperlinks attached in the description below, and we also recommend taking a screenshot of this slide to save the steps for testing later. PageSpeed Insights is a tool you can use to test specific pages on your site. The second contains a report in your Search Console specific to Core Web Vitals. The third is the resource page for the Insights team, which includes the tools mentioned earlier, such as News Tagging Guide, News Consumer Insights, and Real-Time Content Insights. If you want instructions on how to test a specific page with PageSpeed Insights or to find your Core Web Vitals metrics and using the site for Search Console, we've detailed those steps out here. Remember, take a screenshot of this page. A huge thank you to Chris for his expertise, and to everyone watching this video, good luck with your Core Web Vitals and take care.